Hey guys, it's happening again. So, with the COVID numbers rising in my hometown and them mostly getting a lot of the Johnson & Johnson vaccine, I was asked to make another video just kind of explaining the different science with that one. So, going to try to make this as quick as possible. Basically, this is a vector vaccine, which is different than the other two vaccines that are out there now that are mRNA vaccines, which I talked about previously. In a vector vaccine, it takes a different virus, a known virus. In this case, it's adenovirus, which is most commonly known to cause colds. There's hundreds of different adenoviruses. But in this case, they took one of those adenoviruses. They took its DNA, they chopped out the part that makes it be able to replicate and infect people and things like that. They took out the bad part of it and they inserted the DNA for the spike protein of coronavirus. So it is an inactivated adenovirus with the DNA for the spike protein of coronavirus inserted into it. They put that vector into the shell of adenovirus and they put that in the vaccine, and that's what is introduced to your cells. Your cells pick that up, they use their nucleus and their particles in their cells to create the mRNA for the spike protein, which then gets put on your cells and your body sees it, your immune system grabs a hold of it, T cells and everything, and then makes the antibodies to it. So basically, your body is still producing like the mRNA and the other vaccines. It's just kind of a step in addition to that. Like always, I got my little notepad here that kind of breaks that down if you're more of a visual person like I am. But basically, if this is adenovirus's DNA, you cut out the part of it that makes it virulent, that can make it replicate, and then you put in the spike protein DNA of coronavirus. So then you have this new DNA strand that you put in adenovirus's shell and you introduce that in the vaccine. So that's the science behind it. I know some people are going to say, whoa, DNA, changing my DNA. Like, nope, not at all. This will go into your cell, it will go into your nucleus, you will create mRNA from this DNA strand, but it does not change or come in contact or touch your DNA at all. For the record, this is how all viruses work. Every time you get sick, this is what happens. You get a virus that goes into your cells, your own DNA, like DNA viruses that you get sick with that you've heard of, that's how viruses work. So this isn't like, oh my gosh, you're changing me. Like, nope, that's how viruses work. We're just using it to our advantage. So that's the science behind a vector vaccine. So Johnson & Johnson specifically, the numbers here. So people are like, it's way less effective. For the record, it is 85 to 100% effective against severe diseases. Depending where you say severe starts, 28, 49 days, it is 85 to 100% effective against severe cases of COVID. When you look at moderate to severe, it was 72% effective in the US. You hear 65 because they also did trials in South America as well as Latin America, and overall in the world, it was 65% effective, 72% effective in the United States. So yes, 72% is still less than the 95 that you are seeing from the other vaccines. However, you do need to take into account that the Johnson & Johnson trials were done in the winter, more around like December, with new variants and higher caseloads, whereas the Moderna and the Pfizer vaccine started in August with less to no variants and lower cases. So that does skew that number. As well as 65%, 72% efficacy for a vaccine is still awesome. Like, it's a good year of a flu vaccine when we have 60% efficacy. So that's why you're still seeing it out. That's why it's still a good vaccine. So take into account those two things. Also, people are saying one dose. Why do you only need one dose of this? That is just because it showed after the initial like phase 1, phase 2 trials that enough antibodies were being built up at one dose and they were still increasing, so you didn't need two doses. That's awesome. That's good. That's not something you have to be like, oh, that's not as well because you only need one dose. Like, no, they showed that that was enough after one dose. I get a lot of things of, why can't we just boost our immune system naturally, get some vitamin D, vitamin C, all these different things? Yes, do it. 100%. Boost your immune system naturally, fully in support of that. We just need this in addition. So do all the things, boost your immune system naturally. I take vitamin D and C every day. I also got my vaccine. It's kind of a two-parter there. So yeah, boost your immune system naturally, as well as people are saying a lot of different things about different random retroviral medications, ivermectin. You can go down the whole hydroxychloroquine route again. Basically, those didn't show any large-scale efficacy in human populations. You see a lot of research about them in cell cultures that look promising. Once you put them in humans on a large scale in these like larger phase 3 clinical trials, they don't perform. What does perform is the vaccine, and that's why that's out there, and that's why you're seeing that happen. So overall, whatever vaccine you can get, whatever vaccine is getting out to you, get it. They're all approved and on the market for a reason. Yes, they have differences, but hopefully these videos can help you understand the science and feel comfortable with them and make the best decision you can for yourself. But overall, vaccination and getting out of this mess is a team sport. So, I really urge you to consider getting these vaccines. Yes, boost your immune system naturally. Wear your mask, socially distant, get your vaccine, and let's get out of this mess, y'all. Stay safe.